let's take a look at absolute maximum and absolute minimum. So an absolute maximum, sometimes you may hear that called a global maximum. And then the same thing with absolute minimum, you may hear that called a global minimum. Okay, but they're the same exact thing. So an absolute minimum, what that is the highest point of a function. Or of the function. Highest point of a function. So looking at the example on the right, the highest point, so looking there, the highest point of the function here is this point on the right here. Okay, so that is our absolute maximum. It is the highest point in comparison with all of the other points. Now let's talk about some of the other definition words that we've talked about previously. So let's talk about our local maximum. Our local maximum is actually this point here, local max. You could have several local maximum points, but you can only have one absolute maximum, or sometimes there could be 0 absolute maximum points. Okay. Then the bottom point that we have here, that is going to be our local minimum point. Local minimum point. It is lower than all the points near it. When you're probably wondering, why isn't the absolute minimum? The reason why it's not the absolute minimum is because this function continues to go down to forever. It goes to negative infinity. So there is no absolute lowest point. It is only, you can see the local minimum point. Okay, so no absolute maximum in this case. No absolute minimum in this first case. We only have an absolute maximum. So let's take a look at absolute minimum. I'm sure you can come up with a definition for this one. This is the lowest point of a function. So looking at the graph to the right, you can see that this point here is the absolute lowest. So it's the absolute minimum of the function. There's no other points that are lower than that. Then I'm sure you can guess what this next point is on the left. That is going to be your local minimum. Okay, it is lower than most of the other points around it, just not the absolute one. Absolute minimum. And then if you take a look at the last point above, what do you think that is going to be? This point here. That is our local maximum point. Just like in the other example, okay? In this example, the ends of the function go up forever. Okay, it's going to positive infinity. So there is no absolute maximum point. It's going up forever. We can only look at the local maximum point. Okay, so let's use that in this next example. We want to sketch a graph with x-intercepts at -2, 2, and 0, the local max at x equals 1 and x equals -1. So let's sketch what we know, what we're given. We don't really know what degree it is or anything like that yet. But we do know that we have an x-intercept at -2, an x-intercept at +2, and an x-intercept at 0. It does tell us we have a maximum at 1, at x equals 1. So it doesn't matter where you put it, just somewhere along 1. So there will be a max, right? It has to point down. If it's maximum, that means it's the highest point, right? If you do this, that's the lowest point. So that's why I know that it is curved down. Then the local minimum is at -1. Minimum, that means it's making that type of shape. So at -1, that is my minimum point. The x-intercepts are the only places that the graph passes through or bounces. Now, we're just sketching a graph of this function. So just by looking at it, it probably passes through this point here. Then there's a maximum, a local maximum here. Then it passes through the 0, and then it hits the lowest point there, a local minimum, and then it can go up forever. Okay, so that is one possibility of a sketch. We know that this point right here that is our local maximum. Now it's local because that doesn't go up forever, right? Or that is the highest point possible, but it's not the absolute highest because it goes up forever. Same for here. So this point down here would be our local minimum point, just like it asks for. Let's do one more example to the right. Example 2, we have x equals 2, 5, and negative 1. So let's sketch this graph here. We have x-intercept at positive 2 and at 5 and at negative 1. Okay? So we have a local minimum at x equals 2. X equals 2. Hey, that's right where my x-intercept is. That's also my minimum point. Well, in order for that to be a minimum point and for it to be on that x-axis, then it has to bounce off of there. Okay, so if like a minimum or maximum point is also one of the intercepts, then it is most probably a bounce. Then we have a local maximum at 3. So 3, so maybe maximum here at 3, and then a local maximum at 1. Now notice it's not saying absolute maximum. So 3 and 1, I'm going to say that they're at the exact same height. Okay, local maximum. Now, looks like a happy face. So let's go ahead and finish this graph. Sketching this graph, I think it passes through this point negative 1, then a local maximum here, bounces off of the 2, goes up, and has a local maximum at that point, and then goes down again. So this is a possibility of this graph here. Just a sketch. Now, this one, we can say that the degree here is even, right? Because the ends are going the same direction. The leading coefficient in this case is negative because both of the ends are pointing down. Let's look at the other one. This one, we would say that our degree would be what? Odd. And again, our leading coefficient is negative.